All right, this is what I call PySaacSim. It's like a 2D version of PySaacSim where you can use reinforcement learning to train a number of robots in parallel. So you can just place them around a track or any environment and have them learn using reinforcement learning. Right now, the robot my team and I are working on have 3 LiDARs in the front and 2 IRs on the side. And also later, I'm gonna go ahead and show what this looks like in like 10 minutes of training versus 40 minutes of training, so you can see the progress this can make. But anyways, this is the simulation page. So you can see we have 4 robots currently in manual drive, so they'll kind of just go forward, but you can also have them in manual stop, so they act as obstacles, or reinforcement learning, so they actually use the model that you have trained thus far. Next, you have position parameters that you can tweak here manually if you want exact numbers, but you can also just get like a kind of eyeballed location if you just want to place them in kind of randomly just by clicking and dragging or by adjusting these manually. Next, you have the actual play page, so you can play, make the robots move, reset, you can adjust the speed, and here you can toggle whether cars can see each other or not. So this is useful for example, initially training cars to not see each other, just get a good feel for training in a normal environment without moving obstacles, and then you can fine tune it later with moving obstacles. You can also see the live sensor readings right here. And finally, this is just the actual reinforcement learning live training window where you can see all the training happening. Next, you have your track builder. Pretty simple, just click and drag. So you can build a track, but it doesn't really have to be a track. It can be any environment because these black walls just act as, or black lines just act as walls. So here's just an option where you can toggle some of these parameters, and you can also load in a file. Next, you have the robot adjustment page. So like I said, 3 LiDARs in the front, 2 IRs on the side, but you can really adjust these, delete these, do whatever you need with them. And here are a whole bunch of parameters. So you can adjust the dimensions, wheel placements, sensor placements, calibrations, and all of that. So you can make your robot work as closely to the real world as possible. And like I said, there are like saving and loading options. So you can, again, match it to the real world. Next, the controller page. This is a simple dummy controller you have right now, but you can load it from a file. You can load a basic template. You can do a quick paste skeleton directly from C, but you have to know how to format that well. So I mean, I definitely prefer the load from file function. And you also have a simple wall follow algorithm that you can load. And here is the just compile output, just so you can debug if you're having any compilation issues, especially for the quick paste skeleton, because again, you need to format that properly. But that's basically what we have so far, and I'm just gonna go into a quick demo, so take a look at it.